Hi students, welcome to today's class. In the previous class I have explained about local maxima and local minima. Okay, we learned a lot of things there. Now I am going to explain what is global maximum and global minimum. Okay now. So there is a difference is there between local maxima and global maxima, local minima and global minima. Okay now. Generally students will get confused in these two concepts. So now I am going to explain very detailedly, very clearly. Okay now, right. So what is global maxima? Let us see this. Let y is equal to f of x be a function defined in the set of real numbers. Let y is equal to f of x be a function defined in the set of real numbers. Let there is an interval closed bracket a comma b subset are equal to set of real numbers. Otherwise you can define a domain D. You can call it as there is a domain D. Here also there is a domain D. We can call it a set of real numbers, no problem. So here a comma b is an interval which is subset or equal to D. Okay now let us see the graph of this function. Let us see if it is a graph is there. So let us, this is a x-axis and a y-axis and it is a origin. Let the graph of the function, now I am examining the graph of this function in the interval a and b only. That means here in this interval only I am observing. So this is the graph here. Here. So this is f of a, this is f of a, this is some C1 and this is C2 and this is C3 and some of C4 and it is C5 like this, so on. Yes. First to find all the values of f of a, f of C1, f of C2, so on, f of C1 and b. Find the values of f of a1. That means at the end points also f of a and f of b there also. So wherever there are turning points are there, stationary points are there, even critical points are also, no problem, even critical points are there. So critical points are there means if there is a flatness is there here, if it is a flatness is there, this is called a critical point. Here f dash of x is equal to 0 exists, but it is not a turning point. It is not a turning point. Okay now. So for that also find out wherever critical points are there, turning points are there, stationary points are there, everywhere you find out the functional values. So that means you substitute in that function, you will get the values. There you will get, let m1 be the maximum of all the values, maximum of all the values. Let small m, this is a capital M, this is small m will be the minimum of f of a, f of C1, f of C2, so on, f of C1 and f of b. This is f of b, minimum of all the values, minimum of all the values in the interval a and b. Okay now. Then m is called global maximum. Small m is called global minimum. Capital M is called global maximum of the function y is equal to f of x in the interval closed bracket a comma b, and the small m is called global minimum of the function y is equal to f of x in the interval a comma b. That means the least value of all these values, f of a, f of c1, f of c2, f of cn, that is f of b. The least value is called global minimum and the maximum value is called global maximum. Okay now, right. But what is the difference between local maximum and local minimum? I will draw one diagram that will be clearly I can explain to you. Okay. Welcome to this graph. See here, there is a function y is equal to f of x. The shape of that curve is that. If you observe, these are the turning points. These are the turning points. That's all. These are the turning points. In the interval a and b, I am telling. In the interval a and b, closed interval a and b. Okay, now, if you observe, let us say this is equal to C1 and it is a C2 and it is a C3 and it is C4 and it is C5 and it is C6 and it is C7. Okay, let us take that. If you observe, f of C1 is, see here, this value is greater than any value which belongs to, that means a comma b, that is greater than, in this interval greater than. That's why C1 is called, x is equal to C1 is called point of global maxima by definition. Point of global maxima. This is a global maxima. That means remaining all, see here, f of C1, f of C2 is less than f of C1, f of C3 is less than f of C1, f of C4, all values are less than f of C1. That's why x is equal to C1 is called point of global maxima. Okay, now, see here C4, f of C4 is less than any value belongs to a comma b, that is x is equal to C4 is called point of global minima. Point of global minima. So, this C4 value is there, no? This C4 value, this is a C1 value, this is called global minima in that interval. So, there will be a global maxima, there will be a one and only one global minima. In an interval a and b, there is one and only one global maxima, there is one and only one global minima. Understand? This is also sometimes called absolute maxima and absolute minima. That word also using, absolute maxima and absolute minima. Coming to what are the remaining points. So, this is called local minima. This is called local maxima. This is called local maxima. This is called local maxima. This is local maxima. This is local minima. Understand this? Understand, completely understand this? Global maxima, local maxima are different. Global maxima means in a interval, given an interval a comma b, that value is greatest of all the remaining values. That means f of C1 is greatest of all the values. F of C1 is greater than f of C2, f of C3, f of C4, all. That's why it is called global maxima. Here f of C4 is less than remaining all values, functional values of the given function, wherever turning points are there. F of the turning points, critical points, okay, otherwise. But local maxima means if you observe in the neighborhood of C3, f of C3 is the greatest one. In the neighborhood, up to here only, in the neighborhood of C3 neighborhood, very small neighborhood, this f of C3 is the greatest one. That means here increasing, here decreasing. So, this is the highest one. That is called local maxima. Here local minima means in the neighborhood of C6, point 6. Here minimum value and maximum. So, here minimum decreasing and decreasing. It has a turning point. There is a turning point here. Stationary point. So this is called local minima. That means up to that interval, up to that neighborhood of C3, remaining all values f of 6 is the less. That's why that is called local minima. Understand? Local minima, local maxima, global maxima and global minima. From this conclusion, what you can say, global maxima and local maxima are entirely different concept. For in an interval A, B, there will be one and only one global maxima and there will be one and only one global minima. This is a global minima. Global minima. But there exist infinite number of local maxima, local minima, local maxima, local minima. But sometimes that local maxima may be global maxima. Understand? This also we can call it as a local maxima, but it is a maximum of all the local maximas. Maximum of all the local maximas. That's why it is called local global maxima. This is a less than of all the local minima. That's why it is called local minima. So there will be, from this conclusion, we can say clearly, in an interval A and B, in a given interval A and B, there will be only one local global maxima or absolute maxima. There will be only one global minima or absolute minima. But there exist wherever turning points are there, wherever stationary points are there, wherever critical points are there, there you will have a local maxima or minima. Depends upon the, as already I told you. So increasing to decreasing local maxima, decreasing to again increasing local minima. Understand? I hope that you understand the difference between this global maxima and global minima. Now there question arises. What the question arises means, for example, you are taking the interval, closure interval A comma B in that closure interval. So if it is open bracket A comma B, that means there in that interval we are not taking A and B, but the points which lies between A and B. Points which lies between A and B that we are considering. Okay now. So when that case, how to define global maxima and global minima? Let us see that. Dear students, welcome to these two graphs. Observe here. This is a y is equal to f of x function defined in the open bracket A comma B subset are equal to the domain of the function D. A comma B, that means here at x is equal to A, the function is not defined. At x is equal to B, some function is not defined. X is equal to A, function is not defined. X is equal to B, function is not defined. Okay now? Right. That's why I put some 0 marks. Observe the graph here. Here as per the definition, the global minimum is lies at x is equal to C1 is the global minimum. Why? Because f of C1 is the less than of all the remaining values and x is equal to C2 is the point of global maxima. C is the point of global minima. That is clear. That is clear. But while writing the range means here once again I am defining maximum value of that function, first minimum value of that function and the maximum value of that function. That is called range of any function. That we learned in chapter functions. Here coming to range here, the minimum value, global minimum value, that is the f of C1 is the minimum value. F of C2, that is the maximum value. This will give the range and observe here it is closed bracket. Okay now. Observe that graph. See here that graph. Here also the function is not defined. Here also it is not defined. If you observe, this is global minima and it is called global maxima. You may ask one doubt, sir, this is appears to be global minimum. This is appears to be global maximum now, sir. No. Why? Because here we have taken open bracket. Here we have taken open bracket means up to here only you have to consider the graph. Up to here only you have to consider the graph. That means from here onwards you have to take the graph. Here also you have to take the graph. There ends. Here there won't be limit extends to a. Here there is again limit concept will come. Limit extends to a plus, which means that should exist. Okay, now that only positive value exists. And the limit extends to minus, that means from negative side there won't be any, we cannot get anything functional value. Why? Because from left hand side we are not unable to define that function. Okay, so therefore at that point we cannot say clearly whether it is the function is a continuous or not. Okay, right. Here also x tends to b minus will be defined. X tends to b minus will be defined. Why? Because the function from the left side of b will be defined, but the right side of, that means x tends to b plus is not defined, that we are unable to calculate. Understand this? X tends to b plus means from right side, if you approach from right side, here their function is not defined. Why? Because we have taken the function from a to b. The domain of that function is from a to b, that is open bracket. At exactly b we have the left hand side limit, but we don't have right hand side limit. Here we have the right hand side limit, but we don't have the left hand side limit value. That's why at exactly x is equal to a and x is equal to b, even though it appears to be, this value appears to be greater than global maxima, this point we cannot take as a global maximum value. Here also, even though this x is equal to b, but it appears to be minimum of this global minimum value, but that point we should not take as a global minimum value, minimum at a point of global minimum. But see here, very careful. But I have taken the range is equal to, we have taken the range is equal to f of a comma f of b open bracket. Understand? F of a comma f of b open bracket. Why? Because range means what? For all x belongs to the domain f of x, the minimum value and maximum value. Here we will get the minimum value here. So this is a f of a will be the minimum. Here f of b will be the maximum. But we are not taking a is f of a value, we are not taking. Why? Because we don't have the left hand side limit there. But f of a, that means f of a value we are not taking. F of a, that means f of a, the left side of f of a value, f of b, the left side, f of a right side values, f of b left side values we are taking. Range is equal to f of a comma f of b, but this is global maximum, x is equal to some c2, this is x is equal to c1. That means from these two concepts, we will get a conclusion that the range of the function does not lies at the global maximum and value, global minimum value. So generally students will have a opinion that range means global maximum comma global minimum. They have that opinion, but that is not true. Here it is okay, f of c1 comma f of c2. So this is a global maximum and global minimum. But at this type of, if the graph is like this, then in particularly open bracket, when it is a given open bracket, then the range will be the at f of a comma f of b, but open bracket we have to write down. Understand this? I hope that these two concepts you have understood, and you have understood this about local maxima and global maxima are different. Local minima and global maxima are different. Turning points, critical points and stationary points, these all concepts are very clearly you have to learn to solve the problems. Understand this? Okay, so write all these points in a particular notebook and study the points regularly, so that you have a complete grip over that concept. Don't get confused here now. Okay, right. Now, basing on this, let us do very small problems. If you do the problems, then you will have a grip over the concepts that we have learned. Okay, let us see some problems. Welcome to this problem. So, here find the range of the function f of x is equal to 4 cos cube x minus 8 cos square x plus 1. So, that means we have to find the maximum and minimum values. First minimum values and maximum values. Okay, now how to find out? So, shall we draw the graph? So far I have explained all the concepts using drawing the graph. Okay, now. So, can we draw this graph for this function? So, if you draw the graph, that will be what here x is a f of x. X is a real number. So, how many points you will take and draw the graph? So, it is a highly impossible. So, by drawing the graph, you cannot conclude the result. Okay. So, you have to go approach this using theoretical part. Okay. Now, let us approach this problem like this. So, f of x is equal to 4 cos cube x minus 8 cos square x plus 1. Generally, for maximum value and minimum value, where that is called critical points or turning points or stationary points, we have to find out f dash of x is equal to 0. F dash of x is equal to 0. But here finding f dash of x is also easy, but we will approach in a different way. So, let us take another function g of x that is equal to 4 x cube minus 8x square plus 1, where x belongs to closed bracket minus 1 comma 2. So, if you approach this problem like this, the problem will be very, very easy. So, here I am taking cos x is equal to x. Otherwise, you can take y, no problem. G of y is equal to cos 4y cube minus 8y square plus 1, where y is equal to cos x. Y is equal to cos x. You can take y is equal to cos x. Therefore, what is the range of y? Y belongs to closed bracket minus 1 comma 1, like that also put. But generally, we are habituated to do the problems in the variable x. That's why I have taken like that. Now, we will proceed. Now, we have to find out the minus 1 to 1. When there is an interval is given minus 1 to 1, we have to find out the global maxima and global minima. Sometimes already told, so global maxima and global minima lies at minus 1 and 1 also. Okay, now, right. So, let us check that. For that, g dash of x is equal to how much? 12x square minus 16x plus 1. For maxima or minima, so this is equal to 0. So, divide with 4. So, this is equal to 4 3s are 4, 4s are 16. Take x common outside. So, 3x minus 4 is equal to 0. X is equal to 0 or x is equal to 4 by 3. But x is equal to 4 by 3 we cannot take this value. Why? Because 4 by 3 means what? 4 point something. It does not belongs to our interval minus 1 to 1. Therefore, we omit this x is equal to 4 by 3. That may be point of global maximum, that may be global minimum, but our interest is to check the range of this function, that is g of x function, in the interval minus 1 to 1 closed bracket, right. So, at x is equal to 0, that means if you draw the graph here, so this is x is equal to 0, sorry, here this is minus 1 plus 1. Your graph will be here only. That means, so x is equal to 0 is the stationary point. Maybe stationary point, or we can call it as a critical point. So, if you say critical point, no problem. If you say that all stationary points are critical points, but all critical points need not be stationary points, that already. So, we can call it as x is equal to 0 is a critical point, no problem. So, x is equal to 0 is a critical point means what? There the curve will turn. At that point, we may get maximum, or there will be only one critical point, x is equal to 0. From minus 1 to 1, there will be only critical one critical point, maybe this side or like this, or we don't know, only one critical point. Now, we have to check the functional value set. So, we have to check f of 0 value, f of 1 value, f of minus 1 value. So at 1 and minus 1 also we have to check. Why? Because there is a possibility of getting global maxima or global minimum at minus 1 and 1 also. Why? Because it is a closed bracket. Okay. So what is f of 0? Sorry, here g. Our new function is g. New function is g. So what is g of 0? This is equal to 1. G of 1, 4 plus 1, 5, minus 8, that is equal to minus 3. G of minus 1, this is a minus 4, minus 8, minus 12, plus 1, minus 11. So here you see here 1, minus 3, minus 11. So this is the minimum and this is the maximum. So therefore, what is your range is equal to closure bracket 1, first minimum value minus 11 comma 1. Understand this? So very easy problem. Range of this function is minus 11 comma 1. Minimum value is minus 11, maximum value is 1. Okay now? I hope that you understand this solution. So let us go for another problem. Welcome to this problem. So this is a polynomial. Find the range of f of x is equal to 3x power 4 minus 8x cube plus 12x square minus 48x plus 25. Observe this. This is a polynomial with x power 4 is a positive power 4, that is a degree 4. X power 4, x cube, x square, x. The first thing what you have to observe is, for this type of polynomials, the polynomials may be completely increasing or they completely may be decreasing. Okay, sorry, I am telling. So that means in this polynomial, as x tends to infinity, that means if you substitute x value as goes on increasing, limit x tends to infinity plus or minus whatever may be this, f of x tends to infinity. That means as you x value increases, as x value increases, f of x value is also go on increasing. Why? Because it is a polynomial function, clearly. Right. Now coming to how to find out actually, so therefore the maximum value is plus infinity. Now coming to minimum value, how to find out? So for this, what is the derivative of this function? For maxima minima, first we will find out f dash of x. Why you have to find out f dash of x? Always remember, not simply by hearting. Why you have to find out f dash of x? For wherever maxima is there, minima is there. So this is called critical point or turning point. Okay now? So at this critical point, if you draw a tangent, that will be parallel to x-axis. Therefore, at x is equal to a, whatever may be that, f dash of a is equal to 0. At here minimum point also, if it x is equal to b, f dash of b is equal to 0. That is the point you have to remember. So we don't know x where it is getting, x is equal to 5 or 2 or 3 or we don't know. That's why first find out f dash of x equal to 0, find out that x value a or b. Okay na? Right. So find out, so how much this is a 12x cube, 8 3s are 24x square plus 24x minus 48. For a maxima and minima, this value is equal to 0. You can take 12 common outside, x cube minus 2x square plus 12 2s are 24x minus 4 is equal to 0. Again you can take 12 common, from this you can take x square common, x minus 2 plus here you can take common, x minus 2 is equal to 0. So 12 into x minus 2 into x square plus 2 is equal to 0. Okay, now so there are the factors we got. So clearly 12 cannot be equal to 0. X square plus 2 also cannot be equal to 0. This also cannot be equal to 0. The one and only one possibility is x minus 2 is equal to 0. Therefore, x is equal to 2. As already we told that as x tends to infinity, limit x tends to plus or minus infinity, f of x is equal to infinity. That means the function will go on increasing. That means you will have a maximum value at infinity. The maximum value is infinity. So definitely at x is equal to 2, you will have a minimum value. We can call it as a minimum value. Whatever may be that minimum value you will have. Therefore, what is f of 2? If you substitute here f of 2, substitute wherever 2 x value is there, substitute 2, you will get minus 39. So minus 39 will be there here. 2 to the power of 4, 2 cube, 2 square, 2 substitute minus 39. Therefore, what is the range of value is minimum value minus 39, maximum value infinity. Understand this? Okay. I hope that you understand this concept. So, dear students, today I am going to conclude this class. So, in this class you are clearly know the difference between the local maxima, global maxima, local minima, global minima, range we cannot define that global maxima and global minima. Okay, that also I explained this, and in the tomorrow's class I will start problems based on this concept. Okay, until then, all the best.